Hello everyone, my name is Chetan Khandelwal and let's start. First method is root finding method, which comes under and the another method is bisection method. There are some assumptions. First assumption is let fx be the function of a root value x. Then second is we take pair of points a and b and can axis is chosen such that the root lies in the interval a and b, where condition is f a dot fb is always less than 0. The midpoint of a and b is m is equals to a by b, a plus b by 2. Algorithm bisection method. First is root of a, b and e. If root of a dot f of b is less than 0, then m is equals to a plus b by 2, where I is equals to 0. While if m is greater than or equal to e, uh, then do print I, A, B, M and Fm. If f of a dot f of m is greater than 0, then O is equals to m, else b equals to m, and if m is equals to a plus b by 2, then I is equals to I plus 1 and end while print I, B, A, B, M and Fm. And if, and then this is the end of algorithm. Second algorithm is uh, regula falsi method. This is the only, there is only one difference in this method. We make a of fa and b dot fb and construct a second, and we take m is equals to a dot fa minus b dot fb, uh, and b fb minus fa. So now algorithm for cement second method. If read abe, first point is read abe, second is m is equals to a dot fa minus b dot fa by f of b minus f of a, where I is equals to 1. Now condition is while if fm is greater than e, then do print I, A, B, M, Fm, where a is equals to b, b is equals to m. Then m is equals to a dot f 0 minus b dot f 0 divided by fb minus fa. This is the end of while loop. Print iabm fm. This is an end of algorithm. There is another method is second method. Here we do not replace m with b line, falsy position method. Instead we directly replace a to b and b to m in each iteration. And the algorithm for false position method is we read a b e. If f of a dot f of b is less than 0, then m is equals to 0 dot f 0 minus b dot f a but divided by f b minus f a. While loop के अंदर कंडीशन आएगी f of m is greater than equals to e, do प्रिंट करेंगे अपन I a b m f m. if उसके अंदर कंडीशन आएगी if f of a dot f of b is greater than 0, then a equals to 0 हो जाएगा, और अगर नहीं होता है तो b equals to m हो जाएगा. And if m equals to a dot f a minus b dot f e, then डिवाइड कर देंगे उसको f by f b minus f a से, where i कंडीशन जल्दी जाएगी i plus 1 वाइल लूप के अंदर. अब उसका या वाइल लूप एंड हो जाएगा, फिर बाद में प्रिंट करवा देंगे a b m और f m. एंड ऑफ एल्गोरिथम. फोर्थ वन इज न्यूटन मेथड. न्यूटन मेथड के अंदर क्या होता है कंडीशन एफ एक्स इज अ कंटिन्यूस फंक्शन एंड डिफरेंशिएबल इन लिमिटिंग केस व्हेन a is approach to b. So we have d by dx of f is equals to limit goes to b minus a to 0 where f of b minus f of a divided by b minus a equals to f dash x. Now m in this method is given by m is equals to x minus fx by fx. uh, there are some sets, b be any point, e be the be the 0.0001 and m equals to midpoint. Algorithm for Newton-Raphson method. For step 1 is read b, e and I, which is initialized by 1. M is equals to b minus fb by f dash b. While loop, uh, if m is greater than or equal to e, then do print b m f m and I. B equals to m equals to b minus fb by f dash b, where we treat the loop I plus 1. And step 5 is end of while loop. And step 6 print I b m f m. Step 7 is end of algorithm. Now another method is fixed point iteration method. In this method of react finding for fx equals to 0 employs another function gx by writing fx in the form x equals to gx. Gx is known as iteration function. There may be a different gx for fx. For this we have the to choose the one such that either gx or g dash x is less than 1, is either convergent or divergent respectively, where uh, g dash x is less than 1. um, Now algorithm read b, e and n. Step 1, m is equals to gb. We initialize I to 1. We apply while loop. While loop, b minus m, condition is b minus m is greater than or equal to e, and then we do print I b m ab and mb m minus b, sorry. And in while loop we do b equals to m is equals to gb, and I is equals to I plus 1. And at the end of while loop, we print I b m and ibm abs mb, and find, and this is the end of algorithm. The second type of method is interpolation methods. First point one, first 1.1 method, which is Lagrange interpolation, in which we read the number of data, and read xy and y1 uh, up to n, whose corresponding value depend on x is to be determined. Initialize xp is equals to 0. We take uh, iterate values from I is up to n, p equals to z, सेट कर देंगे वैल्यू को p equals to 0, and then फिर iterate the value j to n, and then condition if I is not equal to j, then calculate p equals to p dot xp minus xj, bracket close, x1 minus xj bracket close, and then end of then next j calculate up to yp minus, calculate up to p dot y1x, then print y1, and then we stop, and this is the Lagrange interpolation. Then the second method is divide difference table. This is used for non equispaced data. There are some assumptions. If y is equals to fx by the value of function at any point of x, and second is to be the number of data, t to be the number of data, and ij temporary taken for iteration, d be the array for assigning the value of fx. Now algorithm, there is a start of algorithm. First is start, read n for I equals to j, j equals to I, for I equals to j, n minus j. Step 1, we do 5 equals to 1 if d is dij is equals to yij plus yi plus 1 minus xi, then condition is else dij equals to g ij minus j minus 1 equals to d bracket 1 di dj minus 1 divided by x ij plus 1 minus xi. Another method is backward difference table. Start of algorithm, read number of data, initialize I equals to 1, read yi1, and initialize j equals to 1 to n minus 1, for loop I equals to 1 to the n minus 1. If I is equals to 0, then dij is equals to di minus di plus 1, and then else condition is dij equals to di j minus 1 minus dij plus 1 j minus 1. End of if and end of for loop and end of another for loop, and then we print dij and then end of algorithm. Next method is Newton forward difference interpolation formula. Taking taking one dimensional array x and y of size n. Now algorithm start. Read nx, apply for loop I is equals to 1 to n, and read xy xi y1, end of for loop. Now we apply condition if x is less than xi or x is greater than xn, then print the value lies outside the tabulated range. If end of if and set I is equals to 1 while x is greater than xi, do the I plus 1 iteration. Set I is equals to 1 and end of while loop, k is equals to I minus 1, and then u is equals to x minus xk by xk plus 1 minus xk. Compute the algorithm. Now another method is Newton Cotes formula. An algorithm is we start algorithm, read upper limit and the lower limit, and compute n is equals to ul minus ll by 6. Find the value between ul and ll. Calculate the value of given integrand in the interval and start its value in, and then I goes to n minus n by 2, and condition is f condition not condition formula is f1 plus 2 f2 plus f3 plus f4 plus f5. Print I, and this is the end of algorithm. Is another method is Gauss quadrature formula. Read AB, use for loop up to 5, read xi xj, find now p is a plus b by 2, and q is b minus a by 2. Integral goes to 0. For loop inside 1 to 5, and condition is I is equals to f p plus q x I. Integral is integral plus wi dot fi. And of for loop integral is q multiplied by integral. Print integral. Stop. Method for solving system of spontaneous equation. Now this is Gauss elimination method. Algorithm start, declare variables and read the order of matrix. Take the coefficient of the linear equation and to mention things. And step 4 is do for loop equals to k to n minus 1, initialize kl equals to k plus 1 to n. For loop goes from j, initialize j is equals to k plus 1 and goes from n plus 1 to n plus 1, where I condition is I j is equals to Aij minus Aik divided by Ak plus A by Xj. And step 5 is compute xn is equals to an plus 1 by an. And iterate for loop from n minus 1 to 1. And sum is equals to sum plus akj plus xj. End of for loop. Now xk equals to 1 by akk plus akn plus 1 minus sum. End of k, display the result xk. Stop. Another method is Gauss Seidel method. Algorithm: start, declare the variables and read the order of matrix. Read the stopping criteria. Read the coefficients. Read the coefficient bi for I. Initialize xi is equals to 0, I equals to 1 to n. Set key equals to 0 and iterate for loop from I 1 to n. And repeat for j. And do sum equals to sum minus aij dot. If absolute value of xi to I by xij is, then set k is equals to 0, set x not I equals to minus equals to xi, repeat I. And if k equals to 1, then go to step 6. Otherwise print result and stop. Another method is Jacobi methods. Algorithm: read n, iterate for loop I to n. Another for loop from 1 to n plus 1. And read aij. And read the maximum iteration range. Another for loop I to n. set data. And for loop, iterate for loop from a to maximum iteration. And another for loop from I to n. And another for loop from I to n. Use these conditions and do sum equals to sum a plus aij dot old xij. End of if else. Or now xi is equals to ai n plus 1 minus sum divided by ai by aij. If e is greater than big E equals to e. End of if. End of step 5. Now step 6. If big E is less than or equal to e, then print solution is convergent. It converts the iteration. Now use for loop up to n. And step 7 is use for loop up to n. Set old xi equals to new xi. And end of algorithm. Another method is Euler's method. Let's start the method. Define function. Get the value x0 y0 xn h. Now use for loop up to iterate for loop up to n. And y is equals to y0 plus n fx. Condition up to y0. Now print the value of x0 and y0. X0 and y0. Check if x is less than xn. And x0 is equals to x and y0 equals to y. End of if. And end of algorithm. Then is Rangakutta fourth order method. Read x0 y0 h and xf. Use while loop. Condition is x0 and xf. Print x0 y0 and do the following condition. And end of while loop, print x0 y0. End of algorithm. Now